we derived three equations of circle. The first equation of circle which we derived is standard form of circle. In standard form, we have center as the origin 0, 0 and radius of circle is r. The equation of circle comes out to be x square plus y square is r square. So this is the diagram. So we have only point P, x, y, which is the general point on circle. Center of circle is 0, 0 and the radius of circle is r. Next we derive center radius form. So center radius form is like the standard equation of circle itself, but the center here is h, k and radius of circle is r. So x minus h the whole square plus y minus k the whole square equals r square. This is the equation of circle in center radius form. Center is h, k, radius is r. So the diagram will be like this. Center is h, k, radius is r, and any point on the circle P, it has coordinates x, y. Then we derive third form of equation of circle, which is the general form of equation of circle. It is given as x square plus y square plus 2gx plus fy plus c is equal to 0. Here, the center of circle is minus g, minus f, and radius of circle is root of g square plus f square minus c. So this is the general equation of circle. So we can show it like this. This is a circle. Center of circle is minus g, minus f, and radius of circle is r is equal to root of g square plus f square minus c, all in square root. So these are the three equations of circle which we derived. Now after this, let us move on to more equations of circle. So let us now see the equation of circle in diameter form. So this is the fourth form of equation of circle, diameter form. So as the name suggests, we will have diameter in this case. Now the coordinates of diameter, let us say one end of diameter we consider as x1, y1. This is one coordinate of the diameter. Then the other coordinate of the diameter, let us consider x2, y2. Now we know, let us say this is diameter PQ. We know diameter subtends and right angle at any point on the circle. So let us consider this R as any point on circle x, y. So this diameter PQ subtends a right angle at any point on the circle, let us say R, having coordinates x, y. So we can say slope of RQ, the slope of this line segment, into slope of PR. This equals minus 1. Because this is a right angle, angle PRQ is a right angle. So slope of PR into slope of RQ is minus 1. We have studied this result in straight line. If the two lines are perpendicular, the product of their slopes is equal to minus 1. So these two lines, PR and RQ, they are perpendicular. So product of line segments PQ and PR is minus 1. Now, what is the slope of PQ? So slope of PQ here is y1 minus y, or we can say y minus y1. Y minus y1 upon x minus x1. Y minus y1 upon x minus x1. This is the slope of PQ. And slope of RQ, this thing. So slope of RQ is y minus y2 upon x minus x2. So this is the slope of RQ. The product of slope of PQ and RQ is -1 because they are perpendicular. So MPQ into MRQ, this equals -1. Let us substitute the value of slope of PQ. It is y minus y1 upon x minus x1 into slope of RQ, which is y minus y2 upon x minus x2. This equals -1. So if I cross multiply, y minus y1 into y minus y2, this equals minus of x minus x1 into x minus x2. So let us take this minus on the left side, it will become plus. So y minus y1 into y minus y2 plus, when this minus goes on that side, x minus x1 into x minus x2, this equals 0. We can say from this x minus x1 into x minus x2 plus y minus y1 into y minus y2, this equals 0. So this is the equation of circle in diameter form. So we have studied till now 4 equations of circle. One is, dear students, we derived the equation of circle in diameter form. Suppose we have one end of the diameter as P x1 y1 and another end of diameter as Q x2 y2, and any general point P, let us say R, on the circle having coordinates x, y. So P is one fixed point of diameter x1 y1, Q is another fixed point of diameter x2 y2, and let us say R is any general point on the circle x, y. Then diameter form equation is x minus x1 into x minus x2 plus y minus y1 into y minus y2. This equals 0. So this is the diameter form of equation of circle. So what are the 4 forms we studied? First form is standard form, x square plus y square is r square. Here the center of circle is origin 0, 0 and radius of circle is r. Second is center radius form, x minus h the whole square plus y minus a the whole square is r square. Here center of circle C is h, k and radius of circle is r. Then we studied general equation of circle, x square plus y square plus 2gx plus 2fy plus c is equal to 0. Here center of circle is minus g, minus f and radius of circle r is square root of g square plus f square minus c. Then we have the 4th equation, which is diameter form, where x1 y1 is one end of diameter, x2 y2 is another end of the diameter. The equation of circle becomes x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. So these are the 4 equations of circle we have to remember to start with in this chapter of circle. Now once we have understood these 4 equations very well along with their derivations, let us move on to equation of tangent of a circle. So let us now consider the tangent of a circle. What is tangent? So tangent is the line which cuts the circle at a single point. So let us consider equation of tangent of circle. So suppose we have this as a circle, and at this point, let us say some point on the circle x1, y1, I want to find the equation of tangent. So suppose this is the tangent which we have. This is a tangent. Tangent cuts the circle in only one point. Let us say x1, y1 is that point. Now, to derive the equation of tangent, let us consider the equation of circle in standard form. X square plus y square is r square. So this will be center of the circle, which is origin, and radius of the circle is, let us say, r. Now, if you see carefully, I call this point as, let us say, P. So this CP will be perpendicular to the tangent. So I can say CP is perpendicular to the tangent, because CP is normal. CP is normal. We know tangent makes angle 90 degree with the radius at that point. Okay, so radius vector at that point makes 90 degree. So this angle is 90 degree. So I can say slope of CP into slope of tangent. This will be nothing but -1, because angle between CP and the tangent is 90 degree. So slope of CP into slope of tangent is -1. Now from this I can say slope of tangent is -1 upon slope of CP. Now what is slope of CP? First of all, let us find that. Slope of CP is nothing but y minus y1 upon x minus x1. So y1 minus 0 upon x1 minus 0. So y1 minus 0 upon x1 minus 0, which gives the slope of CP as minus of y1 upon x1. Let us call this equation number 1. Why am I doing all this? Because I want to find the equation of this tangent. So what do we have? Let us see the diagram once again. We have a circle, and on the circle I have some point, let us say P, having coordinate x1, y1. And at this point P, I have a tangent whose equation I want to find. I want to find the equation of tangent at this point P on the circle. So let us consider the slope of tangent as m subscript t. So if I know the slope of the tangent and I know the point P on the tangent, because this point P lies on both circle as well as the tangent. So this point is common to the tangent as well as the circle. So I can say in that case, this point P lies on the tangent, and the slope of tangent I am consider m subscript t. So by slope point form, I can get the equation of this line, which is nothing but the equation of tangent. So I can say equation of tangent is given as by slope point form. So we have studied slope point form in straight line. It is m is equal to y minus y1 upon x minus x1, where any point on that straight line is x comma y. So x comma y is the any point on that tangent. Okay, so slope of tangent m subscript t is equal to y minus y1 upon x minus x1. Now slope of tangent is -1 upon slope of CP. So slope of CP we already found by equation 1. It is minus y1 upon x1. So I can say slope of tangent is -1 upon slope of CP. But by equation 1, I can say slope of CP is minus y1 upon x1. So let us substitute the value of slope of CP. It is minus y1 upon x1. So this comes out to be minus x1 upon y1. So slope of tangent is minus x1 upon y1. So m subscript t is minus x1 upon y1. Let us call this equation number 2. Use this equation to the slope of tangent in this equation. So slope of tangent from equation 2, I will substitute as minus x1 upon y1. So I can say minus x1 upon y1 is y minus y1 upon x minus x1. Let us now cross multiply. So on cross multiplying, we will get minus x1 as it is into x minus x1. This equals y1 into y minus y1. Let us open the brackets. Therefore, minus x1 plus minus or minus will become plus x1 square is y1 y minus y1 square. Let us take this minus y1 square on the other side. So we'll get x1 square as it is plus y1 square is xx1 plus y1. I have taken this term on the right side, this term on the left side. So x1 square plus y1 square is xx1 plus y1. But what is the equation of circle in standard form? It is x square plus y square is r square. So this equation is satisfied by any point on the circle. P x1 comma y1 is one point on the circle. So I can say x1 square plus y1 square will also come out to be r square, because x1, y1 is lying on the circle. So it will satisfy equation of circle, which is standard form x square plus y square is r square. So let us substitute x1 square plus y1 square as r square. So x1 square plus y1 square I will substitute as r square. So r square is x1 plus y1. So from this I get the equation of tangent of circle. X1 plus y1 is equal to r square. This is the equation of tangent of circle. So I can say the equation of tangent of circle comes out to be x1 plus y1 is equal to r square. What is this tangent to? This is tangent to a circle which is x square plus y square is r square. So the tangent to the standard form of circle is given as x1 plus y1 is equal to r square. So let us revise this result once more. So if we have a circle in standard form, which I am writing here, x square plus y square is r square, then the equation of tangent at any point on the circle, let us say we consider x1, y1 as that point, is given by, instead of x square, I will write xx1 plus, instead of y square, I will write y1 is equal to r square. So this is the equation of tangent to circle in standard form. Xx1 plus y1 is r. Students, we just derived equation of tangent to a circle in standard form. So what is the equation of circle in standard form? It is x square plus y square is r square. And what is the equation of tangent to this circle? So it is given as, instead of x square, I will substitute xx1 plus, instead of y square, I will substitute y1, and that equals, this constant r square remains as it is. So the equation of tangent to this circle, x square plus y square is r square, we can get by substituting x square as xx1 and y square as y1. So this is the substitution which will make to get the equation of tangent to a circle in standard form. Here we have the circle as x square plus y square is r square, and we have any point P which is x1, y1, at which we have to draw the tangent, whose equation we have found is xx1 plus y1 is equal to r square, and the equation of circle is x square plus y square is r square. So if we do the same kind of derivation for general equation of circle, so what is the general equation of circle? General equation of circle is x square plus y square plus 2gx plus 2f5 plus c is 0. So here, how will we get the equation of tangent? So suppose this is the general equation of circle which I have written here, and we have a point P which is x1, y1. I want to find the equation of tangent at this point. So let me draw the tangent once again. So this is our point P, x1, y1. At this point P, I want to draw the tangent and find its equation. So its equation, instead of x square, I will write xx1. Instead of y square, I will write y1. And instead of 2x, we have 2x here, 2x. I will write it as x plus x1. And instead of 2y, I will write it as y plus y1. We can do the same kind of derivation. Instead of 2x, I will write as g is as it is. Instead of 2x, I will write x plus x1 plus f as it is. 2y, I will write as y plus y1, and constant c remains as it is. So that equals 0. So the equation of tangent to general equation of circle will get by doing this kind of substitution. We have x square plus y square plus 2gx plus 2f5 plus c is equal to 0. This is general equation of circle. Instead of x square, xx1 as per this substitution. Instead of y square, y1 as per this substitution. Instead of 2x, g will remain as it is. Instead of 2x, we will have x plus x1 plus f remains as it is. Instead of 2y, I will have y plus y1 and constant c remains as it is. So this is the general form or general way to get the equation of tangent to a general equation of circle. And we can do the derivation exactly as we performed for standard equation of circle. So this result of substitution we have to remember. What are the substitutions which we need to do? We have to write x square as x1, y square as y1, 2x as x plus x1, 2y as y plus y1, where x1 comma y1 is the point at which we have to find the tangent for that circle. So this is how all about the equation of tangent to generate the equation of tangent to a circle in terms of slope intercept form of line. So we are deriving equation of tangent to a circle in standard form in terms of slope intercept form of equation of line. So the standard equation of circle is x square plus y square is r square, and we want to derive the tangent in this form. Y is mx plus c. So let us substitute y is mx plus c in standard equation of circle. So I will substitute y as mx plus c. So y I am substituting as mx plus c. So y square will be mx plus c the whole square. That equals r square. So this is our circle, and at this point we have a tangent, and the equation of tangent is y is mx plus c. The tangent, it cuts the circle at only one point. So we have only one point. So only one x coordinate and only one y coordinate. So let us again come back to this equation. X square plus y square is r square. Y I have substituted as mx plus c. So I can write this as x square plus mx plus c. If I use a plus b the whole square, it is a square plus b square plus 2ab. That equals r square. Now, after this, if I take x square common, so it will be x square into 1 plus m square plus 2 mcx plus c square minus r square is equal to 0. Now this is a equation which is quadratic in x. So it's discriminant. So I will write discriminant, which is nothing but b square minus 4ac, that will be 0. Why? Because tangent cuts the circle at only one point. So this tangent cuts the circle at only one point. So we will have only one value of x. So this quadratic equation, it gives two roots, but both the roots should be same. So the discriminant should be 0. So b square, which is nothing but b is 2mc. So b square will be 2mc the whole square minus 4 into a is 1 plus m square into c is c square minus r square. So this equals 0. So 4m square c square minus 4 into, let us multiply these two terms, 1 into c square is c square, 1 into r square is minus r square itself, plus m square c square plus m square minus r square is minus m square r square, that equals 0. Now let us simplify this further. 4m square c square minus 4c square plus 4r square minus 4m square c square plus 4m square r square, that equals 0. Minus 4m square c square plus 4m square c square cancels, and we will equate 4 to 0. So we will have the equation minus c square plus r square plus m square r square is 0. So from this we can say c square equals r square into 1 plus m square, giving the value of c as r square root of m square plus 1. So the value of c comes out to be r square root of m square plus 1. So we have this value of c. The y-intercept is, it comes out to be r into root of 1 m square plus 1. So the equation of tangent will come out to be, so equation of tangent to circle in standard form, it comes out to be y is mx plus c, where c is r root of m square plus 1. So c I have substituted as r root of m square plus 1. So this is the equation of circle to a, this is the equation of tangent to a circle in standard form. Y is mx plus r root of m square plus 1. So we can say the value of c for standard equation of circle comes out to be r root of m square plus 1 for getting the equation of tangent to a circle in standard form. So finally, to comprehend this, the equation of tangent to a circle in standard form is y is mx plus r square root of m square plus 1.